speaker. So thank you so much. That was fantastic, Kasia. So we will, next up we have Allison Sliter. She is a senior data scientist at Digimarc, and she will be presenting data to non-analysts, how to make an impact on all kinds of audiences. Allison, a reminder to start your timer. Enjoy.
I am attempting to share the appropriate screen. Can I get a thumbs up? Does it look good? Kasia, are you the one?
Yep, we can see it. Yep.
Okay, hi, my name is Allison. I'm the senior data scientist at Digimarc Corp. But the senior kind of implies that there might be junior data scientists, but there's not. I'm the only data scientist at Digimarc. I am in the position that I think a lot of data scientists who work in industry are in. I work with really smart people who have a really deep, hard-won expertise in things that are decidedly not statistics or analytics or data science. So to have the analysis that I do make an impact to actually improve the quality of our tools or to make our processes more efficient or even to make good business decisions, my audience has to not just trust that my conclusions are good, but also understand them. So that's where people-centered data presentation comes in. So today I'm going to talk about what it means to center your presentation around people and their brains. It means working with how people perceive information, managing attention, and being aware that your audience comes to the presentation you're giving with their own unique education and background and interest and informational need. Data presentation is the last step in the analysis process, and I think for that reason, it often gets short shrift both in our formal training as well as the time spent in our professional workflows. But it is the method by which your conclusions get communicated. And so without presentation that actually moves an audience, whatever happens before becomes kind of irrelevant. So I'm going to talk, just a quick overview, I'm going to talk about what it means to center your audience in the design of your presentation. Talk about narrative structures that best support data communication to non-analysts and to help you do as much of the cognitive workload of understanding ahead of time, bake that into the way that you present so that your audience can come in, get what they need, and get to the next meeting. One of the great things about being a data scientist is that I get to be a permanent dilettante. I get to learn a little bit about a lot of things. In my case, it's digital signal processing and color science or human-computer interaction, econometrics and market analysis, a lot. But it means that I am fully reliant on my audience. I need the questions that my audience brings to me. So this very first step in centering your audience is to remind yourself exactly how reliant we are on our audience for our jobs. And then next, you want to make sure that you know who your audience is and why they're coming to you. I end up presenting the same data multiple times to multiple audiences. So knowing who is in the audience informs what I say to them and what I emphasize. You need to know why people are coming to your presentation. What is their job? How does what you're presenting relate to their job? What kind of formal and informal education do they have? Are you talking to people who couldn't tell the difference between, don't know the difference between a parametric and a non-parametric test? Are you talking to people who are PhDs in color science? Know who your audience is and make sure that your presentation is focused on them. You also need to speak to your audience. So when we data scientists and statisticians are among ourselves, we tend to get real nerdy, real fast. And when you fail to adapt that style, when you go back to a mixed audience, you end up talking at your audience. And I think we all know what it's like to be talked at. It's a communication style that doesn't include the audience. It doesn't consider their views or their way of thinking or understanding. And it's really depersonalizing. It makes you feel a lot less willing to listen, which is really difficult and a problem when you're presenting, maybe you're presenting bad news. Don't give your audience a reason to reject what you're saying because they don't feel like they're being spoken to. Very specifically, I recommend using plain language as much as possible over jargon. Jargon can be extremely useful in certain contexts. It's precise and can act as a shorthand, but it has to be between people who are fully versed in the same context. And when you have mixed audience, jargon sows confusion. So I'm gonna give you some examples of plain language. Instead of the phrase statistically significant, try if we did this experiment again, it would be unlikely to come up with a different result. I'm not going to read all of these. I will point out that I basically recommend never using the term p-value with people who do not understand what a p-value is. I even hear people who are, career scientists misinterpreting p-values. And when I've given this talk in the past, this particular slide has been very controversial. Some people defending the idea that you should just use jargon all the time because it's the only way to be accurate and precise. But a lot more people just like to argue with the way that I am defining these, the plain language definitions of these jargon terms. So I'm just going to say flat out, it is better to be a little bit wrong or imprecise than it is to lose your audience because you're using jargon that they're not familiar with. When you're in mass communication settings like meetings or presentations or even social media feeds, we constantly filter out the things that we don't think are for us. And one of the ways that we know that it's time for us to filter something out is if it's not in language we're familiar with. We just assume that when it gets technical, it's for some other subset of the audience. If you were doing the same thing in personal communication, your interlocutor would say, hey, I didn't understand that. That doesn't happen in a meeting. So you need to make sure that you keep things in this more vernacular term. If my audience checks out because I'm throwing jargon at them, I really don't have anybody in my audience who is understanding what I say when I say things like, I used a repeated measures ANOVA with a 2-key HSD for pairwise comparisons. I'm talking to no one. You want to make sure to structure your presentation to make an impact. Most of the presentations that I see do not follow the inverted pyramid. They follow a chronological structure. The analyst takes you through the problem that they, in the order that they solved it in. So, you know, that includes all their pitfalls and blind alleys. I was updating these slides just this week. I sat through a researcher's presentation telling us all of the different things that he did, none of which had any conclusions. The problem with this is that it makes the presentation not about the data or conclusions, but about the analyst. And it withholds the most important information, which is the answer, to near the end where people are the least likely to be attentive to it. So instead, I borrowed inverted pyramid from journalism. The inverted pyramid is predicated on the idea that that there is an inverse relationship between how much collective attention you can expect from your audience and how long you've been talking. You never know when someone's going to get a text from the babysitter, or they want to try to slide up for another meeting, or they start checking Twitter. So you want to make sure that the very first thing that you give to them is the one thing that they need to know in order to make a decision. When you're talking about a written communication device, this is a report. This is an executive summary at the top of your report. And then you do a headline, and then you do the body. For a performed presentation like this, it's often unavoidable to do some amount of, oops, sorry, I went back. There we go, sorry. It's often unavoidable to do some amount of like throat clearing, and this is who I am and why I'm here. But you want to make sure that the next words out of your mouth are the one thing that they need to know, their top line results. And you may not actually get to the details that seem most important to you in a performed presentation. I said at the beginning that data presentation is the last step in the data analysis stack, and the data analysis stack is significant, it's big. But what that means is that there's probably going to be a whole lot of your time that it's not reflected in the presentation, and it's hard to cut it out, but it makes a much more powerful picture without the extra stuff. Remember that the goal of data presentation is communication. There's a thing that you know, and at the end, hopefully your audience will know it too. So you want to do the work for your audience and do kind of pre-prepare little nuggets of information so that they can just go and get what they need and go. So that means knowing what you're trying to say and not say ahead of time. When I first started at Digimark, I would routinely talk in public about why I would use a Kendall Tau versus a Pearson's R. That kind of deliberation is always irrelevant. What people want to know is the difference between, what they want to know is that you know the difference between the tests. That's your niche. So statistical deliberations are kept off stage. I create Confluence reports with an Atlassian tool. It's basically just a wiki alongside my PowerPoint deck. So I can add any extra things that I think might be useful or I might use as a reference for later, but then I don't present it. And then, you know, I think I'm not the only one who's heard people do presentations and they, you know, there's somebody else clicking the button for them and they'll say, oh, skip that slide or scroll past that or whatever. If you're going to skip a slide, cut it out in the first place. Or do what I did for this presentation. Hide some slides. You can always bring them back later if you need to. When we make data visualization, what we're doing is encoding numbers into pictures, and then our audience decodes the pictures back into numbers, and that's called graphical perception. So this little widget kind of shows you that different kinds of graphics support more and less error-prone graphical perception. The top, it's more reliable. The bottom, it's less reliable. So scatter plots, for example, use position. And if you've got a grid behind it, that's a line position. Bar charts use length. Time series often try to use angle to show growth. And then, of course, linear regression uses slope. In the end, what you're trying to express is going to have to make the final decision about what you can use. But if you try to move your way up this graph, you're going to get a much less likely that your audience is going to leave knowing a thing that you didn't mean to say as opposed to what you did. You can use visual cues to help your audience home in on what's relevant. You want to put baselines on there, set up parallelism, make sure that you're scaling to the interesting bit. You can visualize confidence intervals and make sure to keep labels close to what they're labeling. I'm going to give examples of almost all of these in the next few slides. So this figure and figures like it got a lot of praise when they first came out. This is showing basically how flattening the curve works. Distributions and rates are some of the hardest concepts to internalize, but when you have this parallelism, you've got two shapes that are similar but different. You can see the contrast. And then because you've got that dotted line that shows you exactly what baseline we're trying to beat, it's really clear what the stakes are around physical distancing and stay-at-home orders and good hygiene. When you have a scatter plot and then you fit a linear regression line, there's lots of different ways you can describe the quality of that fit. An R value is one of them. A P value on that can be helpful. However, R value is something that varies from domain to domain. What makes a good R value? A 0.17 would be a shockingly low R value in lots of things, unless this was something from epidemiology, and then it can be a quite meaningful R value. So instead, what I do is put shaded confidence intervals on to show all of the possible slope lines here, and so you can see, without me needing to tell you that the null hypothesis is that the slope is 0, you could see that there would be some lines that might have a negative slope, and you can see these are null results without having to say the term null results. When you have annotations that have lookup letters, your audience has to do just a huge amount of work. It's like, I have to remember that the thing that I wanted was A, and then look up in a list. But if you just have the name of it right next to it, you short circuit that step, and you can just say, you can see that the antitragus is close to the tragus, and etc. You can see the relationship between things considerably easier. My plots almost always have annotations on them. They'll frequently be the same sort of thing that if I was in person and I was going to point and say, look at this, I'll go ahead and actually annotate it right as close to the data on my figure as possible. So this is a plot that I actually kind of half invented. It's a stacked bar plot, but it has a particular purpose. It's kind of loosely based on the stacking counters that my kindergartner is using to learn basic arithmetic. I call it a horse race plot. This data is from some UX testing that scanned identical baskets of groceries under 4 different conditions. And the width of each rectangle is the average time to bring up that item. And then the sum of the widths shows you the time to scan that basket. So each section is annotated right there so you can see what you're comparing. The colors help draw parallels across position, but they're not crucial to parallels. So even if you've got people in your audience that are severely colorblind, it won't prevent them from decoding this appropriately. And this plot utilizes position and width and all the color encoding to very quickly allow the viewer to answer the following questions. Which condition is the fastest? Which is the slowest? When a basket is slower, is it due to one package doing really poorly, eating up all the time, or is it distributed throughout them? And is there interaction between performance and a particular package? You can see D was fastest, then came B, then A, and then C. And you can see that donuts was slow for everybody. You can see a lot more stuff. And if you spend some time looking at this and you had some context for the data, which of course my audience when I presented this did, you can get a really good idea of a lot of different information all at once. So human memory puts special salience on what comes first and what comes last. So make sure that when you have a conclusion and that it ends on a very clear note. A lot of the time I see people say, okay, what are we going to do next? That can be clear, but you want to make sure to review what you said to make sure in case you lost them somewhere in the middle. So if your audience gets nothing else from their presentation, and they may not, what is a small number of things you want them to come away with? So this is what I want you to come away with. The most important thing needs to come first. When in doubt, say less, not more, and design your presentation for human brains. I'm going to go ahead and leave my further reading panel up so that I can, oh, maybe I can't. I want to pull my questions up, but I don't know if I can while I'm sharing. Is that the case? Do I have to stop sharing?
I'm not. Are you able to see the Q&A at the bottom, Allison?
Oh,
the Q&A button at the bottom of the.
Yeah, I think the real problem is that I was using full screen for my. So we'll do this.
Okay. So just we're going to switch over to Q&A now. Thank you so much, Allison. This was fantastic. Audience, please remember to upvote the questions that you would like to see answered.
So I'm going to start with Victoria's question. What is your perspective of the approach to teach the jargon to your audience? For example, what explaining a p-value means and a p-value under 0.5 is significant. So here, this is actually a big source of the controversy that I mentioned. There are always people who want to do this. My recommendation, so it's a recommendation, it's advice, you can take it or leave it. Don't try. Unless your main purpose is to teach people how to do analysis, don't. Just talk to them about, we clear bright lines, we expected this, we got that. And if your audience wants to learn about, these deep statistical topics, they can come to you. I actually often put all of my statistical deliberations in appendices on my Confluence pages, partially for my own reference, because I'm going to go back and look at it, and partially so that if I get these questions live, I can say, no one else in the room wants to know that, please go look at this. I have ways of tracking whether or not that stuff gets read. They've got analytics, no one reads them. What is a good way to convey limitations of the powers of data analysis methods to non-analysts? Particularly, how do we convey why something did not work to who does not know the technicalities? This is a really good question, and it depends. It's hard to answer in a really general sense, but I do talk about confidence intervals. I just don't say the word confidence interval. So I'll say something like, and this was on the slide there, that we think the true answer is between this and that. So that helps show a lack of precision. I have more than once said, I did not get enough data to answer your question. And then I would do a power analysis, ahead of time and say, I did not get enough information I didn't get enough data to answer your question. This is how much data I think that we would need to do it. Let's do it again. I think that people do understand that there is such a thing as statistical power, even if they don't think of it in those terms. Occasionally, people did not like the analysis results because it does not meet their intuitive understanding. How do you handle that in the presentation? Oh my gosh. This is actually almost a triggering question for me. That is not something that I have figured out how to do before. My approach, and I'm not recommending this because it's not been successful, is to just clobber them with details, pull out my analysis and my written materials and the report, and then just kind of cover them in pedantic details as a persuasive technique. I don't think that actually works. I do think that you can improve things by being really clear ahead of time as to what the question was, to have a well-formed question as to what you're answering. There's actually quite a bit in this presentation that I pulled out about how to get the right information out of your audience. In the end, I decided that was its whole other talk. So coming soon to your next virtual conference, how to interview an audience to get the data information that you want. But I think making sure that before you ever start, that you agree as to what the scope of your data project is and what it would mean to have an answer can short circuit a lot of the pushback that you'll get. Amanda,
thank you, Allison.
Oh, we're done? Okay.
Sorry. Yeah, so one thing that I'm noticing with other speakers, if there some of the questions, if you would like for folks to be able to reach out to you later with their questions, is there a way that they can do that?
Yeah, so back at the beginning here, the easiest probably way is Twitter. I'm Allison S. Early adopter, gotta.
That's fantastic. Hey, Allison, this was fantastic. This is a great talk. I see amazing questions in here and lots of good feedback in the chat. So thank you very much. We are actually, oh, go ahead.
Anybody wants to reach out, like I said, there was a lot that